Welcome to my channel. My name is Beto Fonseca and I want to share a bit of my experience with you and open a space to discuss technology, development and this kind of stuff. In this series, I'm going to develop solutions for some interesting interview challenges that I find in the internet. If you are interested in this kind of content and want to watch other related videos about development and technology, don't forget to subscribe in the button below and click in the bell button so that YouTube keeps you up to date about other weekly videos that I'm going to post later on. Yeah? So, let's begin. So here is the challenge. We have a group of airports here, and we have a group of routes. These routes represents a one way to go from one airport to another one. So for example, in this line here, in the first line, we have a route going from DSM to ORD. This means that we just have a one way to go from DSM directly to the ORD, but we cannot go back. Here you see an example starting in LGA. From LGA we cannot go to anywhere. We are just stuck in the airport. The challenge is, how can we add new routes to the starting airport in a way that we can go to any other airport listed in the graph? So for example, here if we added a new route from LGA to ORD, it means that we can now reach ORD and BGI. But this is not enough for our challenge. We need to reach all of them. So instead of going to ORD, we can move to LHR, which means that we can reach all these sides of the graph. If we added a new route to AWR, then we can reach all this other group. And if we added TLV, then we can reach all this other group. Then we have reached the entire world of this graph. The challenge is, given any starting point, how many routes we need to have to reach the entire graph. Let's begin. So here is my main pie chart view. As you can see, I have nothing installed, just the pip and setup tools in my environment, in my virtual environment. Then let's get started. If you are interested maybe in know a bit more about virtual environments and this kind of stuff in Python, just let me know in the comments below. Maybe I can do a video about that. It's interesting. Let's take a look and maybe create a new main file, and I'm going to just copy and paste the routes. Yeah, so this is the routes that we are going to use in our solution. The solution is basically we want to print a solution for routes and a starting point. So let's say LGA, and it must return like 3 or I don't know, 3 airports so that we can count it or something like that. So in the beginning, let's say that we have here solution. It will receive routes and a starting node, and it must return 3. Very good. So if we run this, 3. Okay, that's nice, but it's just fake. It's not real. Let's turn it real then. Let's begin by creating our graph maybe. So we need to have a graph. A graph will be something like this. So for example, we will have a map of values. So in Python it's a dictionary, and it will say, for example, from sun we could reach, I don't know, LGA, let's say, I don't know, ORD, and maybe del. So del. So it must be something like this. So given a specific node, from that node I can reach a list of possible targets airports, and the target airport can come as for example a new key in my dictionary going to another list of possible airports. Yeah, I think that it's quite good enough. For that I need a dictionary. So in Python we can say that is something like that, or even more easy, we can do something like this to describe the dictionary. But I need a special case of dictionary because I don't want to go to a specific, to have to initialize each item in my dictionary. So Python also have something special for this. So is a default dictionary, and I can say what kind of default value I want for that dictionary. So I will use a set. A set is exactly like in Java, for example, and in other languages. It's just a list of values that cannot be duplicated, so that we don't iterate over and over again in the same values. So let's load this graph. So for each route that we have in our routes, we are going to add in the first item of our route, from the first airport in our route, we are going to add to our set the route that we are pointed to. So in this example here, we have something like this. So in our code, it will be something like graph DSM. We are going to get this set. So we have a default set described here. We are going to add ORD. That is basically it. And just to be sure, because the default, this dictionary here, just add the default value if we have at least the key for it. But in this case, we don't have a key yet for this guy here. And I want to be sure that I do have this. So I'm going to update the route 1 just to be sure that I always will have all the available airports as key independently of it, if this airport has or not a list of target airports. Because in the beginning we saw that LGA, for example, don't have any child, so you cannot go to anywhere. I want to be sure that I get this also. So I'm going to add the route 1. I'm just going to do a hint to it. So I'm going to call update and a new set. What it's doing is we are basically saying, yeah, please give me the value for this route. It has no value, so it will create a new value. And I'm going to say, yeah, please update with a no value set, a completely new set. So it's not going to do anything. Okay. with this we can maybe print a graph to see what is happening now. Okay, so here you see that we have DSM, for example, pointing to ord. That is nice. And if we go but, for example, has nothing. So we are saying here that we have a but airport in the keys of our dictionary, but it's not going to anywhere. So this is the meaning of this. And CDG, for example, it's going to two different places. So we are going to sim and but. So let's take a look in the CDG. We should have two keys here, you see? One's going to sim and another going to boot. So it's nice, it looks like it's working. So let's move on. Okay, so we know from where we are going to where. Now I want to know how deep I can go in the graph, starting from each airport, because I need to know what is the reachable ramification that I can take from each node. So for that, I will create another dictionary exactly like this one. So let's copy and paste, but this guy I'm going to call it paths. This is going to be the map of complete path reachable paths from each node, let's say. Now we need to add an algorithm to search all the nodes that we have in our tree or in our graph. For that, I'm going to use an algorithm called DFS. I got an image from Wikipedia that just exemplifies how DFS works. So from top to bottom, DFS is depth first search. So it means that it's going to the most bottom node that has no child anymore. And from this node, it's going to its parent, and from this parent, it's going to search for all other edges that is below it, and going up again and move on. So for any specific node, we can say that we are going to search in all of its own child node until it has visited all nodes in that sublist. So let's implement it. We need a method for that, so let's call it DFS. DFS is going to receive a graph, the node as a reference, and what we can reach from that node. I think that this is the most important thing. What we need to do, we need to stack the nodes that we are going to search until we have stacked everything and we have visited everything. Yeah. For that, we need to have a stack variable. It's going to be a set, just because I don't need duplications. And why we have something in the stack. And Python, this means that while any iterable, it will return true. So we are going to stay in the loop if there is anything inside this set. If it has nothing inside anymore, it will return false. This is how while iterable works in Python. So while we have something in the stack, we are going to get this stacked item. So stack.pop. As we don't, it's just not important the order that we are going to get from it, because what we need to know is what we can reach by the end. So it's not important, but if you need to do something like the order of it, you can put, for example, the 0 here. It will mean that it will pop the 0 element of this set, for example. Nevertheless, this is not what we need now. We need to get the visited items. So let's create a visited set here, just to stay in track of what we have visited already and not to visit it twice. So if our S item is inside of visited list or visited set, we continue. It's just not important for us. Otherwise, we added it to our visited list. So now we have visited it. Our path is going to be a set of items that we can reach, but I don't want to add the own airport to this list, because for me it don't make sense that it's just obvious that I can reach myself. So because of that, I will avoid to add the node itself to the result. We need to have the result list here, so I'm going to call it a path. It's also a set. So if S is not our own node, so okay, added it to the path. Otherwise, yeah, I don't need it. And I don't need it in the path. And for every edge that we have, let's call it edge, that we have in our graph for that specific node S, we have to add this new edge to our stack. And then it's going to loop again. So first thing is, one thing that is missing here, we need to add it the current node in the beginning to our stack. Otherwise, yeah, the stack it will automatically return false and nothing will work. But first we need to add the node to the stack, and then after that we remove anything from the stack. We check if we visited it. If not, we can visit it now. After that, we check if this node is not our own node that we are starting from. If it's not, added it to the stack. I'm sorry, here we need to add the edges to the stack. One thing that we can also do, Python allows us to do this, what I do like. We have this special way to create for loops. So as we just have one command here, we can say stack and added this edge to my stack set for each edge that we have in our graph for S. It's really a nice way to read the code, so I like to do this. Okay, once we have this, we have to update our reach. So the reach is going to be a set of nodes also. So we can say reach update and added the path to this update. So this reach is going to be what we can reach from that specific node. So anything that we can touch, it's reachable from that node. Yeah. Let's see if it works. Here I'm going to DFS. Well, for node in graph, DFS graph node and the reach. The reach is the path for that specific node. So path is for the specific node that we are talking about now. One thing that we can improve this a bit, I think, is we can do the same as before. So like this, it also works. Now I think that we can print the paths. Let's see. DSM, you can reach LGA, BGI, and ORD. Let's take a look how it works in the graph, just to see. So BGI, we can reach only LGA, you see, so it's okay. From ORD, you can reach LGA and BGI. So from ORD, we can reach BGI or LGA. So it looks just fine. We have here a set of all airports and what we can reach for each of these airports. So it looks fine. Let's move on. Now I have a set, a default this dictionary of all the airports and what we can reach from these airports. But as you can see here, we have, for example, DSM can reach 3 airports, ORD can reach 2, and BGI just 1, and LGA nothing. And then from nowhere, SIN can reach 2 again. I think that it would be nicer if I can just order it by the number of airports that I can reach, because in this case, if I can order the most important airports in the beginning, I can filter out the airports that is already reached, and I can just ignore them. Let's see how it works. So let's have the best path, maybe best paths ordered, or ordered paths. It's going to be a dictionary. Let's do it using some Python stuff. So we can do sorted, and this sorted is going to be on a key map, so a dictionary. So let's put here key value for key and value in paths.items. This items method, it returns each key value of the specific dictionary, and paths here is a default dictionary. It's going to return a key and a set as a value. So basically here I'm just doing a simple sort. Let's try to print it to see how it looks like. Okay, so I have here BGI and then BUD and then CDG. As you can see, it looks like it's ordering by the key alphabetically. That's not what I want. What I can do here, aside of how I can do it, I can say to Python, okay, use this specific key to sort as I want. I can add it here a lambda expression, let's say key value, and for the key value I want the values from the second part. So I want the key value 1. Key value is returning a list of 2 elements. The 0 one is the key and the second one is the value. So let's see how it works now. Okay, nice. It's ordering by the set now instead of the key, but it's not exactly like I want. Maybe. Okay, let's see if this works. Let's see if this works, because it's starting with a null or empty sets, actually not null but empty, and then we have 1 element, 2 elements, 3 elements, and then we have 2 elements again, and then 2 elements again. No, it's not what we need, because we need to get the more reachable airports. So we can do here, we can add it len it's just counting. So please order by counting. If we do this, so we have set, so 3 empty, and then 1, 1, 2, 2, 2, 2, and so on. 3, 3. Yes, that's what we need. So now I'm ordering by the number of airports that we can reach. That's not exactly what I need, because this is ordering from nothing to the most important ones. I want to get the exactly opposite of it. So we can just do hevert it. So hevert this sorted one. So let's take a look. It's returning the iterator of it. But if we do something like this, for key value in ordered paths, then print key value, what is going to happen? It's fine. Really nice. Okay, that's what I need. So for now, what I have is I have this key and I have this value, and I can iterate and say, okay, please give me this guy, added this to my path, to my complete path that I want to reach, and then for any value that has here, I want to ignore in the key, because if it's here, so it's reachable somehow already. I don't care about the rest. So I don't care about what we can reach from it. If it's reachable here, so for example, BGI, if from sun I can reach BGI, so everything that is in the BGI list, everything that's inside BGI list should be here already, because if BGI is reachable by SAN, so everything that BGI can reach is also in this list. I think that it makes sense, yeah? Let's take a look. So what we need to control here, we need the new path. The new path that we are going to build up at the moment. So it's going to be a set, and this set contains the paths of the starting node. Yes, because we already know where we are starting from, so I can already know what is going to be the first look of my new path. And this new path also has to add it the starting node itself, because our paths don't have the parent node or the origin node. It has just what we can reach from. So our new path now has the airport that we are starting and everything that we can reach from that airport. What is interesting here is that on this new path, we need to make sure that the new path contains everything that we have, like the worldwide. So let's create like a world map here, and this world map will contain a set of our graph.keys. So everything that we have as a key in our graph, in our main graph, it's considered our word map, like it's all the airports that we have. And we need to know our new routes. So let's create new routes, and it can be just a list. It's fine. So okay, given this data, for each key and value in our ordered path, we can check first if the key is already in our new path. If it's already in our new path, just ignore it. We don't care about it. As we just mentioned, if an airport is already in our main new path, if it's reachable, everything that that airport can reach is already in our path. So we can just move on. If it's not in our path, then we have to update our path. So path.update, path is set. So update means that I'm going to merge the new set with the current set in our current set, so in this new path. So we are going to edit the value to the new path. And we need to also add the key to the new routes, because the new routes contains what we are adding to the entire list of routes. So new route dot append key. What else? If we do this, I think that it's already going to work, but I want to make sure that's going to break as soon as possible. What I can do, I can check if not len word map dot difference new path break. This is a small hint to make sure that we don't have to move on in our entire for loop if we reach our objective. The word map is the complete list of airports, and the new route is it's not the routes, it's the paths. The new path is everything that we can reach. Let's call it differently maybe, so we can say that it's the reachable. So the word map minus the reachable, so the set of airports removing all the reachable, it's another list, another set. If this set returns 0, then we can remove it. But we don't need the len here also, because it's going to return an iterable, so it's also fine. And here we can return new routes, the len 3. Ha! Okay, but what we can do instead of len, we can return the new routes. So okay, so we can add a route to sun, to TLV, and to AWR for LGA, and it will work. I think that we just don't need this difference. It's just fine. It will work, and it's more simple to read and more simple to understand, I think. So it's fine. So using this solution, if we get, for example, from ICN here, we need to also add a sun, TLV, and TWR. But if we get, for example, TLV, we just need to add the 2 others, or some. It's also going to be just 2, TLV and AWR. As we can see here, from sum, if we are in sum, we already have reached everything here. So all this area plus LGA. But if we added another route to AWR and another one to TLV, then we can reach the entire world. I hope you have enjoyed this video. If you do, please click on thumbs up and subscribe. You can find more content related to technology and development in my own website, The link is in the description below. If you have another challenge that's also interesting, or if you want to use a different language, let's say Java or Kotlin, please comment below. I will take a look and then we can discuss it together. Let's see if this can be the next video. Then see you next time. Bye.